We're going to be using HTML, CSS, and a bit of JavaScript in order to create this, this spinning wheel image carousel. We will be using a bit of trigonometry. It's very light, I promise. I'll explain it along the way. If this interests you at all, stick around. Let's begin. All right, before we begin, let's do what we want visually. So for this video, we're just going to be working in 45 degree or pi over 4 increments. So 45 degrees is equal to pi over 4 radians. And so what we're going to do is we're going to strategically place the images around a circle. And so we have the center of our circle, some sort of x and y that we determine, and we're going to place our images in 45 degree increments around a circle. All a circle is all of the points equidistant or equidistant around a center. So all of these points share the same radius. So if we know the x and y of our center, how do we determine the x and y from the center? How do we determine the x and y of this point? Well, that's where trigonometry comes in. Trigonometry is the study of triangles, but all of those triangles relate to one another using a circle, specifically what they call a unit circle. Now, the unit circle is called a unit circle because the radius of a unit circle is always 1. So all the math of trigonometry is based off of a circle where the radius is 1. So how, with trigonometry, do you determine the x and y from a center? Let's extrapolate this triangle from the circle. So let's say we have a triangle here, and for those of you who don't know, 45 degrees or pi over 4 or whatever degrees you have is from standard. Standard being your horizontal line. You move 45 degrees in this direction and you get this line or this vector right here. This would be 45 degrees. So how do we determine the x and y of this point? Well, we know the x and y of this point. That's the origin. We set that. We know it comes from a unit circle. So the radius or the hypotenuse is 1. We know the radius, or excuse me, the theta or the angle. This is theta right here. This is the symbol theta, is 45 degrees because we want this point at 45 degrees from standard, which is this line right here. So we know theta, 45 degrees. We know hypotenuse. We know the origins x and y. How do we get the x and y of this point? How do we know to move in this direction x, this direction y, and that will give us the arrival of this point? How do we get this? Well, I'm not going to go into the proof of this because I don't know it off by heart, but just take my word for it. When you have some sort of angle, a right degree, that applies to trigonometry. If you take the sine of that angle, you get the y, or the opposite side of this triangle. If you take the cosine of that exact same angle, you get the x, or the adjacent side of this triangle. So using these two formulae right here, we can determine the x and y of any of the points on our circle. Specifically, we're working 45 degree or pi over 4. And so let's go into the code and determine the center of our circle. We're going to be using a div as the center of our circle. But before we do that, let's normalize the page. So let's do a body. We'll do a margin of 0. We'll do a padding of 0. We'll do a width of 100 viewport width. We'll do a height of the same 100 viewport height, 100 VH. And let's create that div for our center. We're going to call it the wheel. There we go. Let's do a width of 300 pixels. We'll do a height of 200 pixels, and we'll make it blue so we can see it. So background color blue, and let's place it in the page. So div dot wheel. There we go. Save. Let me scroll up just a bit. All right, so we have our div. Now let's shift this div to the center of the page, because if we construct the circle right now, the left images and the top images are going to be cut off. So let's transform this guy. So we're going to be using position absolute. If you don't know what I'm doing with position absolutes and lefts and right, I'll have a link in the description below to a video I did on position and display. So left is like our x coordinate. We're going to move it 50% of the page. We're going to do the same with the y, which is the top, which is our y coordinate, 50% of the page. We save, we go back. And so the way HTML works is that it positions elements based on the top left corner of that element. So this right here is the center of the page just for the sake of aesthetics. Let's move the whole box to the center. We can do that with a transform. So we'll do transform like this. Form, we'll do a translate like that, and we'll just move negative 50%, negative 50%. Let me delete this line, save, go back. So we have the wheel, quote unquote wheel, that we're using in the center of the page just for the sake of aesthetics. We didn't need to do this. Wherever this wheel goes, that's where the images are going to go. So let's make an image right at the center, which we need to do. We're going to make an image or a card right in the center of our wheel. So the class for that, we'll just say card. We'll do a width of 90 pixels, a height of 50 pixels. We'll do background color of red. Let's place it in the wheel. So down here, We'll do a div.card, enter save. All right, so let's shift this guy just like we shifted the blue guy away from the top left of our page. We're going to shift the red guy away from the top right of the parent, the blue wheel. So we can just copy and paste the exact same code. Position left, top, and transform. Put a space in here. We'll save. We go back. All right. So we have our first image, or we'll make images later. We're just going to deal with divs or containers right now. Our first card, our first container, our first image in the center of our quote-unquote circle. Using trigonometry, let's place this guy 45-degree angle, at a 45-degree angle from standard. So to do that, we're going to be using these guys right here, sine and cosine. So let's capture that card in the JavaScript. So we're going to say const card1 document.query selector, query selector, and the class was card, not class, card. There we go. And card1.style.left, which is x. And then we can do top, which is y. And the left is our cosine. So we need to do math.cosine of 45 degrees. Let's put that in a separate variable. So theta is equal to math. And in math functions, they don't work with degrees. They work with radians. So 45 degrees is equal to pi divided by 4. And there we go. So let's put that theta in here. And we can just copy and paste this code here. And the unit for this, for left and right, is of course pixels. So right now we have an integer, we need to make it into a pixel. So pixel would be something like this, px. There we go. And convert this guy into pixel as well. There we px, and there we go. Let's save, let's go back, and what's going on? Well, right now, when we've established this code right here, this offsets our little card by a certain pixel x and y. When we reestablish an x and y for our left and top, we're forgetting about this initial offset. And so we need to bake in this initial offset into the formula here. So we need to capture the original center of the card and then add the sine and cosine offset. So I'm going to do that with an object doing this. Const center, and the x of the center is just going to be, to get the x and y, or any style of any CSS you've applied to an element, you can use a function called getComputedStyle. You add or give in the element, and then you can use or find out the property or the value of any style. Specifically, we're looking for our x, which is left, and we're looking for our y, or top, which is y. And this is all a string, so we need to convert these strings into integers or floats so we can use them. So we're going to do parse float like that. And for this guy as well, same thing, parse float. So parse float like that. There we go. And let's add that back here. So we need the center.x plus the offset. And then we need the center.y plus the offset. We save, we go back. Now, what's going on? Well, it did shift, but all the mathematics of trigonometry are based on a unit circle, the unit being 1. But 1 pixel relative to our canvas is astronomically low. I think the sine of theta, or sine of 45 degrees, is like, what is it? It's like 0.9, and the cosine of 45 degrees is like 0.6. So this whole image right here, this red guy, shifted 0.6x and 0.9y. You're not going to be able to see that on our canvas. The pixels are way too small. So we need to magnify the radius of our math for our functions. So let's go back here. Let's say let wheel radius. And we're going to say, let's magnify by 150, see what that looks like. And so we're going to put it here. We're going to say what you're going to give me here, which is like 0.6, multiply that by 150. So we get a bigger or larger, something where we can see the actual shift. So same thing with the y, times wheel radius. We save, we go back. All right, so we have kind of what we want. We can see the shift happening, but why isn't it 45 degrees here? Why is the 45-degree angle going down here? Well, it has nothing to do with the math. That has everything to do with how the canvas or the page is set up. For your x-axis, the left is negative, the right is positive. And the y-axis is kind of counterintuitive. The top is negative, the bottom is positive. So we just need to invert the y values using a -1. So we can just do a -1 like this, -1.0 times, we save, we go back, and there we go. We have a 45-degree shift from standard of our image. Now let's go back into the code, and we're going to create a loop, and we're going to put, how many more images? 1, 2, 3, 4, 5, 6, 7, 8. So 8 images, 7 more images around this circle. but not manually, using a loop. So let's go here like this. 1, 2, 3, 4, 5, 6, 7. That's 8. That's 8. And instead of capturing one card, we're going to capture all the cards, plural. So this should be a query selector all. And the class is card. Now we don't need to have a new center for every single card because all the cards share one center. That's why the math works. So we can start the loop down here. So we can say cards.for each, and we'll get the card. And we need the index for something I'll show you in 2 seconds. So cards, there we go. We can take this, put this in here. All right, this should be cards, or not cards, just individual card. And we're going to take all this math out of this because it looks gross. All right, so we need 3 different, to clean this up, we'll use 3 new variables. We'll do new theta. That's going to be the theta of each individual card's offset, or what we're going to use for the math. We'll just set that at 0, and we're going to do a new x and a new y, just so it looks cleaner. A new x, and then we'll do new y, like this. So we can go down here. And so the new theta, let me just do it quickly right here. How do we determine the theta of, how do we get our theta to be 0 here, and then our theta to be 45 here, and then 90 here, and I think it's 135 here, don't quote me, and then 180 and so forth. Well, we're going to use the index of our loop. Our index goes from 0 to 1, 2, all the way to 7. We're going to use that, and we're going to multiply it by pi over 4, or 45 degrees. So the first card here, the theta should be 0. So 0 times our theta, or 45, is 0. This guy's image, or excuse me, his theta should be 45 degrees, or pi over 4. The next index is 1. 1 times pi over 4 is pi over 4. So we're going to use that property to get the theta of each individual card. So the new theta is going to be equal to our constant theta, which is pi over 4, times the index. And then we just get the x and y for this guy. So we can just copy this. That's going to be our x, and this is going to be our y. And so I can delete all this stuff here. This is just going to be new x, and this guy's just going to be new y. New y. So let's go new x is equal to, and we'll go new y is equal to, and we don't need the px part, we don't need that part. All right, format, let's do some spacing. So for our new x, it doesn't take theta, it takes the new theta plus or times the wheel radius, that's good. And this should be new theta times wheel radius and times -1, which flips the y-axis, which is good. And then we have the center, which is constant throughout all the cards, plus the shift in x, plus the shift in y. Let's save and go back and see what we get. Now, why aren't we getting anything? New theta, pixel, pixel, parse float, wheel radius, new x, center, card, for each, query selector cards. Here we go. So the card 1 right here doesn't exist anymore. So we're not getting an accurate x and y. We can use any of the cards because they share an x and y. So we'll just use the first card. Doesn't matter. So cards, there we go. And 0, bracket, bracket. Now when we save, we go back. There we go. So we have all the images strategically placed around a center using trigonometry. Let's just expand the radius because it's kind of too cluttered. Let's do, I don't know, 200. Let's see what that looks like. All right, that looks better. Kind of looks like a U flag. All right, let's. What are we gonna do now? Let's rotate the entire wheel. So we're gonna need to do 2 things. We need to capture the wheel. Let's do the wheel here. Const wheel is equal to document dot query selector. We'll capture the wheel. There we go. And now we need to listen for my mouse to scroll down. So we're just gonna add in the document a listener. So document. Add event listener. We're going to listen for, I think it's wheel, and we'll inspect the event to see what property we need. And we'll just console.log the event. We'll save, go back, keep my console. I'm going to scroll down. All right, so let's see what we need to track our mouse wheel. Now I've done this before, and there was a bit of a hiccup. So depending on what you're using at home, when I use my mouse wheel, actual mouse, because right now I'm using my trackpad. When I use my trackpad, this guy works right here, delta Y, but it doesn't work with my mouse wheel. This works with my mouse wheel. But since I'm using my trackpad, I'm going to use the delta Y. If you're using your mouse wheel at home, code for the delta Y. So I'm going to take the, code for the wheel delta y. Because I'm using my trackpad, I'm just going to take the delta y right here. So that's the speed at which y is changing. So let's go back into the code, and let's say let scroll speed equal, what was it, event dot delta y, like that. And that's going to give me, I don't even know if that's a number. Let me just check something real quick. Console.log event. Let's go type of event.delta y. Let's see what it is. Number. So it's already a number. I don't need to convert it. I thought I'd have to parse it. So that's going to be the scroll speed. And then we're just going to rotate the wheel here. Now, when we do the wheel like this, we're going to wheel.style. Let me just show you instead of just fixing it first and then showing a transform. And then we're going to do a rotate like this. And we're just going to rotate by, now we're going to need a theta here. So we're going to do rotate by event dot, oh, we don't even need that. This should be backticks. There we go. So scroll speed, rotate by scroll speed and theta. So theta plus the scroll speed. So the theta where it starts here plus scroll speed. So we're just rotating around an angle like this. We'll save, we'll go back, and scrolling down, what's going on? Why isn't it working? I forgot the unit of measurement should be degrees. So this one uses degrees, and it's going to come back to bite us just a bit. I'll fix it later. All right, so what's going on? Why is it shifting like that? Why is it rotating like that? Well, two things are happening. So when I do a transform here, this rotate, it's overriding this rotate right here. So we're taking away the translate. So let me just refresh. So the translate is applied right now, so it's in the center. When I rotate, because I didn't code for that translate again, it goes back to its original position, so there's no translate, but it does rotate kind of wonky. So we need to bake in the translate, just like we baked in the center. We need to bake in the translate here. So keep the translate and add the rotate. So negative 50%, space, we rotate, or excuse me, we save. I scroll down, and we still get this effect. What's going on? Well, the theta right here. This theta is a constant pi over 4, 45 degrees. So when we start out our rotation of this the wheel, the theta is right here. I scroll, I stop. Where's theta now? Is theta here? No, theta always starts here. So it's always starting and stopping here. Starting, and no matter how much I scroll, it starts here, stops here, starts here, stops here. So we need the theta to track with us. So let's just do a wheel theta. So we have a wheel radius, go let's wheel theta equals 0. It'll make more sense when I write it like this. So my wheel theta, or the theta we want to use for our scroll speed, our scrolling, let it be the wheel theta is equal to the previous wheel theta. So keep track of wheel theta plus the scroll speed like this. So I can delete all this and just put in the wheel theta. Wheel theta. There we go. We save, we go back. I'm scrolling, and there we go. So we have the full image carousel scrolling. Now, visually, it looks like what we want. On the back end, just a little, I don't know if it's OCD or what it is, but just understand that this math right here, wheel theta, this is being used in radians, but it's translating to degrees. Now that's okay because it does what we want. I'm scrolling fast, it looks fast. I scroll slow, it looks scroll. But just to be slow, but just to be consistent, we want to convert this guy into degrees. And to do that, we just multiply by a ratio of 180 divided by pi. And that's going to change how the thing scrolls. So I go back, I scroll very slowly, and it's going way too fast. So we need to modify the scroll speed. So we're just going to do, I don't know, 0.02 like that. Let's go back. Let me scroll slow. There we go. Scroll slow, scroll fast. That's better. So not only does it look good on the front end, but the math is consistent with degrees on the back end. Now I'm just going to clean this up, and then I'll show you guys the end product. So I've gone ahead and just replaced all those divs with these images right here, and then given them a border radius to make them round. I've given them box shadow. Let me show you what the code looks like. So just taking out those divs, put in images, the exact same class card. I've modified the class to not be a set width, height, background. I've added the border radius, box shadow. The positioning is exactly the same. For our body, I turned overflow hidden because it was doing this. So when I scroll down, it was giving us these sidebars here, which looked disgusting. And so I turned off that with the overflow hidden. And there we have our final product, a wheel radius image carousel. If this video helped you at all, don't forget to give a like, subscribe if you haven't already subscribed, and I'll see you guys in the next video.